In this video, I would like to go over the concept of permutations, which is a concept in section 9.6 of our textbook. This will be the second video in this section. Alright, well, I'd like to go over these three formulas, permutation formulas, and I'll give you an example of each one. Alright, well, the first formula, consider the following example. A horse race, and consider that there are 5 horses labeled A, B, C, D, and E, and the question is, in how many ways can they finish the race? Alright, well, I'm going to put 5 spots here for first place, second place, third place, fourth, and fifth place. Alright, well, first place. How many horses can take first place? Well, there are 5 horses, and so any one of those 5 horses can take first place. But once first place is already taken, how many spots are there for second place? And the answer is 4. And once first and second place have been taken, how many spots are there for third place? And the answer is 3, and then 2, and then 1. So the answer here for in how many ways can the horses finish the race is 5 factorial. 5 times 4 times 3 times 2 times 1, which is equal to 120 ways. Alright, now consider if there were 7 horses. Well, then the answer would be 7 factorial. If there were 10 horses, 10 factorial. If there were n horses, then the answer would be n factorial. And that's the example, that's using the formula number 1 up here. All right, let's move on to the second formula. Okay, an example of the second formula is consider again the horse race between 5 horses, and this time, however, the only thing that we're going to care about is first place, second place, and third place. We don't care about the other, fourth and fifth place. So let's consider these 3 spots then. All right, how many horses can take first place? Well, again, there are 5 horses, and one of those 5 horses can take this. 5. How about second place? And the answer is, once first place has been taken, there are 4 horses that can take second place. And then once first and second place have been taken, then there's 3 horses left that can take third place. And so the answer is 5 times 4 times 3, or 20 times 3, 60. Now, there's a formula that I can use for doing the same calculation, which is formula number 2. It's n p r, where n is a subscript and r is a subscript. This is the permutation of n elements taken r at a time. And in this case, there are 5 horses, so n is 5, and then p for permutation. And I'm only interested in the first 3 places, first, second, and third. So I'm going to let r be 3. So n is equal to 5, and r is equal to 3. Okay, well, the formula is up here. So I'm going to do 5 factorial divided by 5 minus 3 factorial. And if you work it out, you're going to get 60, which is the same answer as I got up here. All right, the third formula, consider the word banana. And the question I'll be asking is, in how many different ways can I arrange the letters in the word banana? So if I use this formula here, I'm going to let n equal 1, 2, 3, 4, 5, 6. 6 because there are 6 total letters. So I'm going to get 6 factorial divided by, now down here on in the denominator, I have n with the subscript of 1, and then 2, 3, 4. These are different n's from the one I have in the numerator. These are for repeating letters. Repeating letters. And so the word banana does have some repeating letters. The first one is A, so I'm going to say that n1 is 3, so 3 factorial. Times, are there any other repeating letters? Yes, n. So n repeats twice, so 2 factorial. And if you do that calculation, you're going to get 60. So there are 60 different arrangements that I can do with the letters of the word banana. And in the same way, you can try the word Mississippi and see if you get this same answer, 34,650. So these are 3 permutation formulas that we use in section 9.6. Another example in which permutations are often used are, for example, consider a race for president and vice president, or let's say an election of president and vice president from a group of 10 people. All right, so in this case, we care about 2 spots. Out of the 10 people, any one of them can be elected for president. So there are 10 choices for president. But once president has been taken, for vice president, there will be 9 people left that can take vice president. So the answer here is 10 times 9, 90. And using the formulas up above, we can we would get the same result if we did n is equal to 10 and r equal to 2 positions. And then use the second formula, 10 p 2. If you do this calculation, you would also get 90. And that is it.